Now, have you ever thought about the rainbow formation? Rainbow is a natural spectrum appearing in the sky after a rain shower. Okay, and what is the cause of rainbow? It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. So, the tiny water drops present in the atmosphere behaves like the prism. And whenever the sunlight passes through the tiny water droplets, it splits into its spectrum of colors. Okay, see here, this is the sunlight, and sunlight enters into a water droplet. So again a refraction occurs here because light is entering from air to water, from rarer to denser medium. So refraction will occur, and refracted light is incident on this face of the water droplet in such a way that this water droplets is this light is totally reflected back. So consider this light. On reaching here, it undergoes refraction, and the refracted light is incident on this face of the water droplet at an angle such that the whole light is reflected back. Okay, and just think about this light ray. It is also totally reflected back. So here what is occurring here, reflection is occurring, and on reaching here again the light ray passes from water to air. So refraction occur, and the refracted light will be deviated in different angles, and we are able to see the spectrum which forms the rainbow on the sky. So in the formation of rainbow, we can see the dispersion phenomena, we can see 2 refraction phenomena and 1 reflection phenomena. Okay, so on the sky you have lots of tiny droplets. Okay, and all the spectrum formed by all these water droplets, which acts like the small prism, forms a beautiful rainbow in the form of an arc. Okay, so a rainbow is always formed in a direction opposite to that of sun. So there are some conditions for the formation of rainbow. Do you know the conditions? First one is that rainbow is formed soon after the rain, isn't it? So one part of the sky must be filled with water droplets, and the opposite part of the sky, on the opposite part there must be sun, because sunlight must be there. Okay, and also sun must be behind the observer. Then only the observer can see the rainbow. Okay, so a rainbow is always formed in a direction opposite to that of sun. So here on the screen it is very clear, sunlight is coming from the opposite direction on the water droplets, and here rainbow is formed. So sun is lying on the opposite direction of rainbow. Okay, and this water droplets and the atmosphere act like small prisms. They refract and disperse the incident sunlight, then reflect it internally, and finally refract it again when it comes out of the raindrop. So due to the dispersion of light and internal reflection, different colors reach the observer's eye. You can also see a rainbow on a sunny day when you look at the sky through a waterfall or through a water fountain with the sun behind you. Okay, so you must also remember this particular ray diagram. It is also important, and just look at the deviation of violet and red. Okay, so the red is deviated least with respect to ground, but violet is deviated most with respect to ground. Next, we can discuss another interesting concept in our nature, that is atmospheric refraction. Children, you might have observed the apparent random wavering or flickering of objects seen through a stream of hot air rising above a fire or a radiator. So here you can see the objects are getting wavered or flickered. Flickering of objects is observed here, but actually it is not happening. We just feel like that. So that's why we can say it is an apparent observation. Okay, so usually it is observed above a fire or a radiator. So why does it happen? See here what is happening. The air just above the fire becomes hotter than the air further up. Okay, see if we consider here is that fire, and the air above, just above the fire is hotter than the layer of air just above it. Okay, then the hotter air is light. It is lighter. So it is less dense than the cooler air above it. So here the air is cool and here the air is hot. So this air will be less dense, and this layer of air, cold air, has more density. So if there is a difference in density, there will be difference in the refractive index also. Okay, so since the physical conditions of the refractive medium are not stationary, the apparent position of the object as seen through the hot air fluctuates, because there is a change in the density of the air between these two layers. So refraction occurs, and due to the refraction, the apparent position of the object as seen through the hot air fluctuates. This wavering is thus an effect of atmospheric refraction on a small scale. Okay, we can see similar phenomena in nature on a much larger scale, that is twinkling of stars. So twinkling of stars is due to atmospheric refraction of starlight. Okay, we can discuss about twinkling of stars in more detail. Children, what is this twinkling of stars? Here you can see a boy. He is observing the star, and this is the actual position of the star. This is the apparent position of the star. So what could be the reason for the shift in position of the star? So you can see the boy is standing here and he is observing the star on the sky, and a lot of atmospheric layers are there. So here is our actual star, and the light from the star enters to the atmospheric layers, and due to the difference in density of the atmospheric layer, because different layers of atmosphere have different density, and due to the difference in density of the atmospheric layer, the light ray coming from the star undergoes refraction, and due to the refraction it will bend its path and finally it reaches here. It bends its path and reaches the observer's eye like this. It cannot move in a straight line path because of the continuous refraction. Okay, it will bend its path like this. But our eye has a problem. Our eye always follow a straight line path. Okay, so our line of observation is always along a straight line. So this boy's line of observation is along straight line path like this. So this boy feels that star is here, light is coming from this position. So according to this boy, star appears here, even though this is the actual path of the star or position of the star. So this is the actual position of the star, and this is the apparent position of the star. Apparent means we feel like that, it's not an actual position. Okay, so this happens due to the continuous refraction suffered by the starlight by the different atmospheric layers. Okay, so due to the continuous refraction, the light ray bends and reaches the boy's or observer's eye, but the boy's line of observation, sight of observation, is along a straight line. So the boy feels that light is coming from this particular point, and star is here. And what could be the reason for the twinkling of the stars? You know, the atmospheric condition is not steady or stationary. Sometimes refraction takes place more, sometimes less refraction occurs. So due to this changing atmospheric conditions, sometimes the star appears bright and some other times the star appears dim. Okay, if more refraction occurs, then star appears to be brighter. If less refraction occurs, then the star appears to be very dim. Okay, so there will be a continuous switching of star between the bright and dim position. So due to this, we feel that the stars are twinkling. So this is the reason for the twinkling of stars. And what is the cause of twinkling of stars? That is atmospheric refraction. Okay, so this is the twinkling effect of stars. Another phenomena which can be related with the atmospheric refraction is that advanced sunrise and delayed sunset. You know, it sounds interesting. The sun is visible to us about 2 minutes before the actual sunrise. Suppose the sunrise occurs at 6 o'clock in the morning. So it is visible to us at 5:58. That means 2 minutes just before the actual sunrise. And also it is visible to us even after 2 minutes after the actual sunset. Okay, suppose the sunset occurs at 6 o'clock in the evening, but the sun is visible to us even at 6:02. That means 2 minutes even after the actual sunset. So all this interesting phenomena occurs due to the atmospheric refraction itself. Okay, so here what happens? You know, this is horizon. You are familiar with horizon, isn't it? And whenever sun is below the horizon, we can't see it. Sunrise is there, and whenever sun crosses the horizon, sunrise occurs. Okay, as long as sun is below the horizon, we cannot see the sun. This is our concept. So is below the horizon. This is the position of the actual position of the sun. That means sunrise has not taken place. So the light from the sun moves through the atmosphere, and on reaching here it needs to cross the different layers of atmosphere. And since there is a difference in density in the atmospheric layers, it undergoes refraction, and due to that refraction the sun's rays undergo continuous bending and finally reach the earth's surface like this. Suppose an observer is standing here, but his line of observation is along the straight line. So he observes the sun here because his line of observation is along this straight line path. So according to him, sun is here. That means above the horizon. But sunrise has not taken place yet. So even if the sunrise has not taken place, observer feels that sun is above the horizon, that is at this position. That means according to him, sunrise has taken place. So this is the apparent position of the sun. This is the actual position of the sun. Due to the atmospheric refraction, observer feels that sunrise has taken place. And the time delay or the time gap between this observation is 2 minutes. So that's why sun is visible to us 2 minutes before the actual sunrise. Now what if in the case of sunset? Suppose sunset has taken place. Okay, sunset has taken place. So if sunset has taken place, sun is below the horizon. Again the same thing happens. Sun's rays reaches the atmospheric layers, undergoes continuous refraction, and it will bend, reaches the observer's eye. But his line of observation is along the straight line, so still he can see the sun here. So even if the actual sunset has taken place, he can see the sun here. Sun is visible to him even after 2 minutes after the actual sunset. Okay, so this interesting fact occurs due to atmospheric refraction. Okay children, so that's all about atmospheric refraction and the interesting phenomena related with atmospheric refraction. So with this I am concluding this session. We will meet in the next session. Notes of the topic and YouTube video have been uploaded. Please go through it and attend the test paper seriously and post me the answers quickly. Stay home, stay safe, keep learning. Thank you.